To start off, as we proceed into this webinar session, we acknowledge the First Nation, Inuit, and Métis nations and communities that have been harmed by colonialism and unethical research practices, and of the data sovereignty and research priorities of these groups. On behalf of the Digital Research of Canada, we're committed to understanding and taking up a role in reducing harm and advancing reconciliation in research. The Alliance seeks to provide a welcoming, engaging, and safe community for everyone. Discriminatory language is not appropriate in any venue or platform. The Alliance does not tolerate harassment in any form. I have the pleasure today to introduce Felix Anton Fortin, who is the Director of Software Development at Calco Quebec and the lead for research software development at the University Laval. He's been with Calco Quebec since 2015, where he's played a pivotal role in supporting the non-traditional users of advanced research computing resources, ranging from digital humanities to big data and artificial intelligence. Felix Anton is particularly known for his work in developing and supporting services across the Alliance, enabling research to utilize advanced computational resources effectively. His innovative approach and dedication has earned him recognition both within the research community, including the Award of Excellence from Compute Canada. And with no further ado, I'll hand it off to Felix. Thanks, Felix.
Thank you, Ben. So yeah, as Ben said, I'm the Director of Software Development at Calcul Quebec and principal instigator of Magic Castle, which is a small research software that is widely used, at least at the Alliance, to train how to use high-performance computing clusters. Now, full disclosure, today's abstract might have been or not written by artificial intelligence. Ben actually wrote that abstract for me. And 5 days ago, this talk did not exist. I had a quite September and October busy schedule, so I'm doing my best to provide you like valuable content in terms of developing research software, secure research software. But there might be some king to address during this talk, and feel free to raise your hand, stop me while I'm talking. This is a conversation, and the main point I'm trying to make with this talk is that I'm not a cybersecurity specialist. I write research software, I write software. We are in this together. We are, all of us, I think, are writing software, not necessarily that is secure, but there are experts out there that maybe we can reach out to and learn about. So as I said, this is the beginning of a conversation. This is I think the research software community inside of the Alliance is growing at a certain pace. And I think if you'd like to talk more about research software and be excited about software as much as I am, you can at least join us on Slack on the research software channel, which is available also to users or to researchers, and the software dev channel, which is mainly, I think, open to staff currently, but there's wide open to discussion around research software and also about the secure aspect of research software. So when Ben asked me about could I do this talk, and then he wrote that fantastic abstract, I had to come up with some slide to begin with to fit that abstract. And my first thought was, well, in order to produce secure research software, I think, and I would like to ask, or collectively, I think we would say that in order to produce secure software, you have to follow the best practices of research software development. And it happens to, so last June during an internal conference called DRI Connect, the organizers asked me to do a talk on best practice in research software. So I thought, yeah, you know what, I'm going to use that presentation as a starting point. And if you like to go see it, it's available on YouTube. I'm putting the link. It was a decent presentation on what I thought would be the best practice in order to build research software. And so the idea was that fun fact where we will go from the idea of what is the research software to an actual product. And I used to some quotes from the Hitchhiker's Guide to the Galaxy to guide us through that journey. And my last slide, which resonated with some of the people in the room, was that research software actually has a life cycle. It's born, it lives, and eventually it dies. Now, plan ahead, expand to more. Now, plan ahead. That was the important part of actually the life cycle, I thought, was you have to think about the life cycle of your research software. But now, as Ben asked me to do this talk on secure research software, I started thinking, well, how can we actually introduce security in that research software lifecycle? So I started thinking, well, what is actually a research software lifecycle? And I guess somebody way more intelligent than me could have come up with what's the actual research software lifecycle. So I kept digging. And I found out that there's this fantastic org called EOSC in the EU, in the European Union, that came up with this diagram of what the actual software lifecycle looks like. But they don't necessarily address security inside of that lifecycle. And if you are already familiar with just software development lifecycle, that essentially is the main part. The center of it is essentially what we are used to in terms of developing software, but what they have introduced in terms of what the research component part is, you have to define your research question. So how are we going to integrate security when you're actually defining your research question? And planning, that's usual, but then there's a publication and community feedback. And recently, we've seen that community can sometimes be a threat to actual software. If they are badly intended, they could try to introduce some malware into your software. So how can we actually look at that life cycle and maybe introduce security in that? So I kept digging. And eventually I asked, so I have my colleague at UVic, Drew Lesky, and he's the lead of research software at UVic. And I started asking, well, what do you think? How do you think we should introduce like security into the research software lifecycle? And he said, well, I don't know, but you know what? Recently, one of my staff started looking at OWASP and the application security verification standard, and I was like, "What was that?" So I kept looking. So I fetched the application security verification standard, and oh great! There's actually a section on lifecycle which called secure software development lifecycle. So I said, "Aha, bingo! I have 2 days to do my slides. I'm going to do it on that secure software development lifecycle." So if you're not aware, just who by raise of hand, who knows what is OWASP? 2, 3, 4, 5, 6. All right, not bad. So 4, 3, 2. What? It's moving. So let's say a quarter of the room are actually aware of what is OWASP. So OWASP is called Open Web Application Security Project. So it's a foundation, and the goal of the project is to provide an open application security standard for web apps and web services of all types. But it can be it can be fairly stretched to research software in my humble opinion. And it provides all sort of tools, and it's overseeing plenty of projects, and one of them is of interest for today, as if we go from the application security verification standard, the actual first point of that application security verification standard when it comes to lifecycle in the latest release is to verify the use of secure software development lifecycle at all stage of development. So I said, great. Now what is C1? And C1 was actually one of the top 10 proactive controls of OWASP. So what we're going to do today is just go. I want to do top 10. We don't have much time, and it would be pretty boring. Again, this is the beginning of a conversation. And as I was going through the proactive controls that are provided by OWASP, I was like, this makes so much sense. And I'm glad that actually someone wrote it down so I can like pass it up to an intern or pass it up to a junior, or even refresh or look at some of the tools that are related to some of these proactive controls. So this is fantastic. Now, some of you who were already of OWASP, how many of you knew about proactive controls top 10? Three participants raise their hand. Perfect. We're in this together. So number one of the top 10 is to implement access control. Now, what they say is that upfront, you have to design access control, whether it's role-based access or attribute-based access. So these are the two models which you can implement access control. It doesn't matter, but what they say is that when you are starting to build your software, you should already think about building access control in order to limit access to the data or the functionality of your software. Now, every access request should go through access control. There shouldn't be any bypass or backdoor or some aspects that are generally public. At least make it go through the access control and then make sure that everyone has access. There should only be one access control. Makes sense. And then it's I wouldn't say number four. I do this. It can be painful, but by default, you should deny access to everyone, and then you should provide access, which is the principle of least privilege, right? You should only get access to some resources explicitly, not the inverse. And they are providing an interesting snippet of code where they are saying, well, you shouldn't hard code actually roll. You should instead you should make sure that attributes of a user are available. So if you'd like to provide a user the ability to delete account, instead of looking at does it have a role of manager or a role of admin, you should explicitly look for does that user actually has permission to delete an account, and then it can delete an account. Now it's subtle, but keeping that in mind when you're writing software makes you potentially write more secure software. Now, second aspect is to use cryptography to protect data. Now, again, makes perfect sense, but devil's in the details, right? When you are building your research software application, you should at first, at the very beginning of when you are again planning and developing your application, but at all aspects when you are actually potentially adding data to your application, mostly that comes from the outside, you should make sure to classify that data and determines which level of sensitivity each piece of data it belongs to. Now, if possible, avoid storing that sensitive data when possible, when at all possible. If and to determine if that data is sensitive or not might change from region. If you're in Quebec now, there's all bunch of new data that used to be not so sensitive that legally has changed. So if you have that plan of all the classification in place, new legislation comes in, you can review that classification. But if it's all in your head, it might be difficult. So having that all written down will help you in the life cycle of your research software. Now, you're at the point where you are actually have to store sensitive data, make sure you use encryption. And then they propose those three like pretty I would say it again makes full sense. When using encryption, make sure to follow these three rules. Never transmit or store plain text data. Do not create, and for God's sake, do not create your own cryptographic protocols, and do not implement cryptographic routines. There are pretty much there are whiz out there that are that eat cryptography for breakfast. Please trust those people to do the right thing instead of being of trying to do your own crypto stuff. But on the other hand, what you can do as a software developer is be crypto agile. Now, I found that term pretty, it sounded like a buzzword, but it's when you look at it, the concept is pretty decent. Make sure that when you select an algorithm or when you select a number of bits of encryption, for example, make sure that you don't hard code those notion, but make them configurable. So if at some point RSA 2048 bits is no longer enough secure, make sure that you can switch RSA for something else, and or that you can increase the number of bits quite simply. So when it comes to encryption, and then again, if you're not implementing your own stuff, it should be pretty, and you're relying on external frameworks, it should be pretty easy to swap these things out and make sure that you are able to swap these things out as the crypto ecosystem and landscape is changing and new threats are emerging. So be crypto agile. Maybe you are already, and now you can claim that you're crypto agile. But if you're not, think about it. Uh, this is again pretty common knowledge that you should validate all inputs and handle exceptions, but we are software developers. We all tend to be lazy. At some point, we're like, you know what, this there's no way that data could they will find a way to actually provide you malicious data. So never trust provided data, even if it's your own, I would say, because sometimes we do provide messy data on our own, and it can mess up with your application. So if you are at the very beginning designing your application to validate the data, and they in in the top 10 they are actually explaining that you have to validate two aspects of your data. You have to validate the form, which they call it, I think, semantic and or syntactic, and the accepted range, which is the semantic, or I don't know which is which, but doesn't matter. So you should, even if that data is actually as the right form, you should validate that it is in the right range in order to avoid all sorts of issue that could come up with data being out of range of what you expected. When it comes to web application, you should validate all the data ideally, and not ideally. All of the data should be validated on a server side, but from a usability standpoint, you should still provide validation on the client side. So so for a security standpoint, you need to validate that data is in the right range and is in the right form, so you don't process it and potentially execute uh, malicious intent data. But from a usability standpoint, you want to provide feedback to your user as fast as possible that he made a mistake when providing you data. So you don't want to go through the old loop of first going through a server, then getting back an answer and saying your user, sorry, the data you submitted is in the wrong form, because at some point you will either lose them or lose them, and or they will start feeding you bad data if you're keeping if you're putting too much latency in that loop. And fifth, it again makes full sense, but keeping this in mind that even if a data looks only like a data, at some point it could translate in your code into actually code or commands that are being sent on the server side. So avoid executing data as commands and cost at all costs. And I've put it the classic SQL injection uh, graphic in the slide to remind you that at some point, something that looked like just an input from your user, its name, its username, an ID, uh, when badly validated or unsanitized, could end up being a command in your database. The fourth aspect of the top 10 is to address security from the start. And again, those things are like everyone saying, well, I'm writing good software, right? I'm following principle, but revisiting those principle, I think on a fairly frequent basis is a good idea. If you have never read The Art of Unix Programming, it's full of designing principle that are inspiring at least. You don't have to follow them by the letter, but keeping uh, those are important principles that will make sure that you are potentially writing uh, good software and that you are writing software that follow best practices. And again, by writing software that follow best practices, it has way better chance of being secure than not. So they provide these different principles that are uh, might sound familiar. If they don't sound familiar, I invite you to go look at them. All were all written by fairly savvy people into software writing. And then again, sometimes we tend to say that the second aspect is build on established third parties or build on established frameworks. Or so sometimes we tend to be, well, while we are software developers, we tend to be lazy. We also tend to say, well, it's not exactly what I want, so I'm going to rewrite it from scratch. The, on the beginning, we have already stated that from a crypto standpoint, that's a no-no. But there are other aspects where you can build faster software faster if you rely on frameworks, but also frameworks that are being heavily used have way more chance of being secure and being heavily vetted by other people that are more securely competent than you are. But in order to benefit from those frameworks, you have to make sure to keep them updated. It's while, for example, if you were using Django 1 at the time of its release, it was a fantastic software, but now we are Django 3, it's time to move on. Please update it. But they also say, well, if the framework is not exactly what you want to do and you're adding all of these exceptions, don't fight it. Just move on to another framework, or like there's a point where maybe a third-party framework is not the right solution for your but keep that in mind. Like at least start with it and maybe move on with if you have fair reason to move on from it. The fifth one is one that quite resonated with me because of the infrastructure as code stuff. But what they say is that secure by default configuration. So opt for a configuration that would be secure by default and then introduce exception if needed only. So configuration should be based on the least privilege principle. So for example, if you are creating an S3 bucket, just make sure out of the box that it is private. You deny access by default instead of allowing all by default. Use container image that have been scanned. So there are like bazillions of container images that exist with bazillions of intents, some of them being malicious. Make sure that you are using images that have been scanned by tools at first. And one of a pet peeve of mine, prefer infrastructure as code over manual configuration. So if you are building a server, if you're building a service, make sure that you are defining that service as infrastructure as code. So as a declarative language that both if in case of issue with your server or in case of issue with your application, you can tear it down and rebuild from scratch because it's all code. That's way better. But also, if your infrastructure, if your application, all of it is actually through code, it can be audited. And then it can be statically analyzed. And for example, there's this nice tools that is being referred in the top 10, which is called TFSec. So if you are using Terraform infrastructure as code, you can go through, you can put it through Aqua TFSec, and then it's going to tell you whether there's some issue with your configuration in terms of security, which you won't be able to do or not as easily if, for example, you have configured your virtual machine or your application directly manually. The best you could do would then be to actually scan or pen test your application from there. But it's better to actually analyze at every step and even potentially integrate that scanning of or that analysis of your infrastructure in your continuous integration. So that's an interesting tool, again, that is being referred in the top 10. And finally, as I said, we are not doing the 10 out of, I selected the first 6. So keep your components secure. As stated in C4, you should ideally leverage libraries and frameworks from third parties, but not all of them are equal, right? You have to identify the one that can be trusted. And if you don't know how to do that, they in the top 10, they are providing different aspects that you should look at when selecting a framework, whether it's source, popularity, activity, maturity, complexity, and security. And those tends to change over time. So you have to monitor those aspects and you have to keep them secure. So if you have selected this framework or this third party, you have to make sure you will perform a continuous check. And I've put a bad example of not doing a good job at being proactive in checking. So if you are on GitHub and you're receiving dependabots alerts, please look at them and don't do it like I do and just ignore them because they are annoying. If you are getting if these tools exist, but you have to act on these updates that are being suggested by the tool, and uh, you have to tools like dependabots are cool, are called software composition analysis, and you have to put it you have to start using them and integrate it into your software development lifecycle early on and often. And you have to make sure that if there's an update, you don't push it back, that security update. Just apply it. As painful as it is, if there's security update, make sure that you can apply it as fast as possible, because down the line in the life cycle of your software, there's plenty more that is coming. So you better get to develop the right workflow to integrate new activity and security update. So you're getting used to it, and it's less and less painful as your software is evolving. So key takeaways: you're not alone when it comes to security inside of your research software application. At least there is OWASP that exists. There's plenty of more. I'm sure. Today we went through OWASP and one of its flagship. I think there are over 360 projects that are being funded by OWASP. Now, and its mission is pretty clear: improve security, software security through open source initiatives. So you can just benefit from it, or even if you have something to contribute, since it's open source, you can contribute back. And what they say is, and I fairly agree, that adopting the OWASP top 10 is perhaps the most effective first step towards changing your software development culture focused on producing secure code. So I think that's, and going through the actual top 10 is, maybe you can read that in an afternoon. It's pretty, when we leave that call, if you've never looked at the top 10, I invite you to just go look at it, skim through it, and I'm pretty sure that you'll find plenty of very useful resources for the software that you are even currently developing. Now I open the floor for discussion, and I would like to ask, like, at what stage of your research software application you would like the Alliance to help with your in terms of security in that aspect, and also how could, or how could or how should or how would the alliance help with your secure application development? Whether it's, do you need more training? You need to go deeper into the top 10 and be provided with like example in Python or in your language of choice of how you could apply those principles. Would you need to once your application is deployed on, for example, the Alliance Cloud, would you like some teams or tools to be provided for pen testing or for systematic vulnerability checking of your application? We do it. I think we do it already for some on some aspects, but the user don't have much to say on what is being actually scanned. Or do you actually need specialized security software licenses? So those things can be pricey at some point. Is there something that could benefit the whole community when it comes to security software? Maybe. Our final hat tip to Benjamin for writing that great abstract that with me that got me on that road of exploring OWASP and top 10. Jules Key for pointing me in that direction of OWASP. It was a great talk. And Maura for looking at and proofreading those slides. I'll open the floor. If you have talk, question, comments, you can also reach to me on via email at felix@calculquebec.ca. Thanks, everyone.
Yeah, Felix, we have a couple questions in the
All
Q&A
right.
piece. Maybe I can read them off and
Yep.
what do you think is the often most overlooked aspect in this topic? And, it would have a big impact if addressed. So you went over the top six. So of these top six, do you have one that you think sort of stands out?
I think implementing access control is often overlooked. And as they say in the top 10, if you are going back on your research application and try to implement those role or those attribute based access control, it's going to be a pain. So and I've seen it. So I'm a very small contributor to Jupyter Hub, and they went through the actual very painful process of going from not having RBAC to implementing RBAC into Jupyter Hub, and it was both a very painful for developers, and it's now very painful for user to wrap their head around the new model that is being proposed, while the previous one was just let's keep it all open or just define a few admins and you're good to go. Now all of these roles are being retrofitted inside of Jupyter Hub, and it's for the best, but I'm from an external point of view, it was painful. So if you are at an early stage of developing your application and you want to make it secure, and there are users with different roles or different that should have different security level, make sure to look at implementing access control early on. I think it's difficult to come back on that.
No, no, great answer. Yeah, there's another question in the Q&A piece. The question is, what role does automated testing play in ensuring compliance with things like OWASP?
I think there are things that are proposed by OWASP, and OWASP actually have tools to make sure that some of these are that you can automate some of these. But on the other hand, like what I've shown you here. So the secure software development lifecycle aspect of OWASP, while it was part of version 4, in version 5, they removed it entirely. And I suspect that it was because it is it is actually difficult to automate and be an actionable item inside of your CI/CD. So those are more like general principle on which you should make sure that your team is aware of early on, and that is part of the design. But then once you have made your choice of not following, for example, the cryptography principle and you have implemented your own secure stuff, there's no CI/CD that's going to detect that. Like there's no static analysis that's going to tell you, hey, you're being dumb. Use RSA instead. So I think there are some like I've only covered one page of the application security, not even of the application security verification standard, and I think it's 100 pages of things that are actionable. But when it comes to life cycle, I it's those I don't think those things are actionable into a CI/CD, but there are plenty of stuff that are actionables, and I think OWASP has potentially a lot of projects that make it easy to integrate into your CI/CD.
Yeah, just encourage folks to keep the questions coming in. One last question, unless there's more in chat. So given the 6 steps of the strategies that you've sort of mentioned here, what should we do to get developers sort of within the research environment to buy into OWASP? And that's sort of tied into your earlier question. Is there anything you think we can do?
I think at first they need to be aware. I think awareness and training and just and it has to. So those are, and I only like barely scratch the surface of what is actually proposed by OWASP. And I've not even so if you start looking at the document, they provide actual example of that might resonate with the developers that will make them more, I'll say, sensitive to the concept. And it's just I wouldn't try to get a team of developers like sensitive to the general concept of OWASP. I would be more sneaky about that. I will like say, you know what, you're working on something that is related to sensitive data. Could you just look at this aspect of the OWASP, and then they'll like just don't focus on the force that is OWASP with all of these projects and all these tools that are available. Just you have a potential problem with sensitive data. Look at what are the recommendation when it comes to implement how to work with sensitive data and how to classify your data, how to design that application to make sure that you are correctly implementing access control, and then just slowly integrate that in your workflow, and you'll grow as you are, I'll say, more familiar with the concept. You'll look into other aspects of your work that maybe are would could get some uh I'll say shining or some work in terms of security. And then proactively I think developers will be more sensitive on that secure stuff of developing yeah.
Yeah, no, great answer. Great answer. So that's the last question from Q&A. Any sort of final comments before we sign off, Felix?
Thanks again for the alliance, and Ben for reaching out and giving me the opportunity to go through this fantastic tool that is OWASP Top 10. I'm again, just if you are part of staff, make sure to join the different channel that we have. If you're a part of user, we have this research software community that is slowly building, where we are looking to building this forum where we can discuss more and in more details of how to build secure research application.
Yeah, seeing as there's no more questions, appreciate the talk, Felix. It was great. I posted those 2 channels in the chat. Encourage folks to sort of join them in Slack, and appreciate everybody's participation in October Cybersecurity Awareness Month. And we'll see you again soon, and
All right.
we'll sign off. And so thank you very much.